Alright, here goes with our lesson video for Unit 2, Day 3. In fact, if you want to go ahead and write that at the top of this page, we're going to start off with the name that property. Okay, Unit 2, Day 3. We're going to get to something called geometric proofs, and we're going to talk about segment proofs in this lesson. But first, we're going to do a quick little review of what we learned in the previous lesson over algebraic proofs, and that's where we covered some property names and what they meant. So what I would like for you to do is just use matching here. Match the statements with the properties of equality given here, and you might use them more than once. Okay, I'm going to do a couple of these with you, and then I'm going to have you pause the video to try and complete this, and then we'll check the answers as we go. All right, first off, if k equals 3, then 3 equals k. Anytime you reverse an equation to turn it around, that is the symmetric property of equality. So that's H. Symmetric POE. There's an abbreviation for that. Okay? We'll use that anytime we're doing a proof where we have to change the equation around so that it's in the correct order. And then the next one, if 2x equals 14, so we treat this as our given statement, what do we do to get to this equation, x equals 7? You would take this equation and divide by 2 on both sides. So that's the division POE, D. And anytime we have something equals itself, a value equal to itself, that's the reflexive property of equality, G. So why don't you go ahead and give yourself some time to fill these out. Do not just try and check the answers by continuing to watch the video. Try these yourself. Go ahead and give yourself a little bit of a challenge. Pause the video, try and come up with these answers, and then you can check your work. But if you're just going to copy them down, that's not going to help you a whole lot. So please make sure you are taking advantage of everything I ask you to do. Okay, if you have tried this on your own, you should be ready to check your answers, and we should get this. All right, 4, we should get A, the addition property of equality. 5 is I, the transitive property of equality. 6 is E, distributive property. 7 is B, subtraction property of equality. 8 is F, the substitution property. 9 is C, multiplication property of equality. 10 is I, transitive property again. 11 is A, addition property of equality. 12 is H, symmetric property. 13 is F, substitution property. 14 is C, multiplication property of equality. 15 is G, reflexive property. And 16 is E, the distributive property. Okay, even though it's written in reverse order, it's still the distributive property. So let's go ahead and continue with the rest of these notes. All right, that's just a quick review over these algebraic properties. Okay. So now we should be moving on to segment proofs reference. This is over geometric proofs. We're going to split our topic of geometric proofs into 2 parts. The first one's going to deal just with segment proofs. And so I'm going to just kind of go through how to work on some segment proofs. We're going to do a little bit of notes, and we'll do some more work in class together to figure that out. But we're still going to be working in 2-column proofs eventually, but we're just going to go over some properties of equality and then some properties of congruence. So first thing I want to point out is any property of equality we abbreviated with POE after, property of equality. But these new properties I give you are of congruence. That's this symbol, okay, not just an equal sign. Property of equality is dealing with just an equal sign, but if you see this symbol in your statements, you're dealing with a property of congruence, and we would abbreviate that as POC, property of congruence. So these will be done differently because we have reflexive, symmetric, and transitive properties of equality, but we also have those properties of congruence. And any of the rest of these are only equality properties. Notice the list of properties of congruence is much shorter. So we're going to talk about what these mean, but it's the same general idea, but we are going to use congruence statements instead of equality statements. So the reflexive property states that for any segment AB, segment AB is congruent to segment AB to itself. Notice I didn't just write AB, I wrote the notation for the figure. We're not stating values are equal, we're stating figures are congruent. The symmetric property, very similar. If I say that segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Changing the order of the congruence does not matter. And then lastly, the transitive property. If I say segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then the original segment AB is congruent to the final segment EF, because these are congruent to the same thing. So we're linking them together with that common segment CD and just taking that shortcut. Okay? And this could work if it had 3 separate segments, or 4 or 5, or if you have any segments where they're all congruent to each other, any one is congruent to any other one. Okay? So we're going to talk about some definitions here. The definition of the word congruence. Segments are, this should be congruent, not congruence. Segments are congruent if and only if, there's your if and only if statement, they have the same measure. So we can say if AB equals CD, if these lengths are equal, then segment AB is congruent to segment CD. Or if we flip that around, we can say if segment AB is congruent to segment CD, then the length of AB, measurement, equals CD, also measurement. So anytime we change from stating that segments are congruent to their lengths are equal, we're using the definition of congruence. Remember, definitions can be used as reasons of a proof. Okay, we would abbreviate that as definition, parentheses, the congruent symbol. Definition of congruent. Okay, that's how we can abbreviate that, so we don't have to write it out long ways. Okay, and then the definition of a midpoint works out very similarly to this. The midpoint of a segment divides the segment into 2 equal or congruent parts. So if M is the midpoint of AB, then we can write this. AM equals MB, or because of that definition, we could say segment AM is congruent to segment MB. Okay, we can state either one of those by the definition of a midpoint. We would abbreviate that as def, for definition, of MDPT. That's the abbreviation for midpoint, MDPT. All right. So we have one other piece of useful information here, and that's our first postulate of the year, and that's called the segment addition postulate. Here's how you abbreviate that. Segment addition postulate. Now, we have already covered this. Okay? We have already done this in Unit 1, but I'm going to reword it so that it fits the characteristics of what a postulate is. A postulate in geometry is any statement that needs not be proven. It is so basic and factual that we don't have to prove that it's true. We just accept it as true. So if we have collinear points A, B, and C, and B is somewhere between A and C, not necessarily in the middle, just anywhere in the middle, then we know the sum of the parts equals the whole. Part plus part equals the whole thing. So we can say AB plus BC equals AC. Again, part plus part equals whole. We did that last unit. But this is a reason we would use in a proof, segment addition postulate. All right. So now we're going to take a look at some practice problems to finish this out. Okay, we're not going to do all of these in this video. I'm going to do a few, and then I want you to try and finish these before you come back to class. Now, I've given you a property bank to use, so we're going to use these words or expressions, these properties of equality, or properties of congruence, or definitions or postulates, for our reasons for these statements. Okay? So first off, if PQ equals PQ, then segment PQ is congruent to segment PQ. You might be thinking, well, that equals itself, so that's the reflexive property. If that was our statement, PQ equals PQ, our reason would be reflexive property of equality. Or if that was our statement, segment PQ is congruent to segment PQ, then that would be reflexive property of congruence. But when I put it in an if-then form and I combine these, I'm changing the emphasis of what I'm saying. We're saying if segments are equal, then they're congruent. So if segment lengths are equal, then they are congruent. That is our definition of congruence. Okay, definition of congruence. And so we write definition, parentheses, congruent symbol. Okay, that's our abbreviation. Okay? Number 2, if K is between J and L, then JK plus KL equals JL. These are the parts. Okay? It might help to draw this as a picture. K is between J and L. Well, then you're adding part plus part equals whole. So that is our segment addition postulate. So our second answer is segment addition postulate. Okay? I want you to go ahead and try and do 4 through 12. Finish these problems out. I'm sorry, 3 through 12, the last 10. Do 3 through 12 on your own. Okay, that's a 3. Kind of looks hard to see in the video. That's a 3. Finish these out before you come into class, and then we will check these together as our warm-up to make sure you have the right answers for 3 through 12. All right? Probably ought to use pencil. That way, if you need to fix anything later in class, you can do that.